So in this video we shall continue from where we ended. In the previous one we saw how to use the difference of two squares to simplify. Now here we are going to see how to use this identity here, the difference of two squares, to factorize. In most cases, say if we are given two terms, but when we can express each one of those two terms as a perfect square, meaning we can put a square in each one of them, then to factorize, we can apply the difference of two squares. And hope you also remember that factorization is writing what we are having as a product of more than one term. So if we are given a question like say number 1, and they tell us to factorize 7 squared minus n squared. This is the difference. We are having the first number squared minus the second number squared. The two numbers squared and the sign between them is subtraction. So what we can do is, they want us to write this as a product of two terms or more than two terms. So we shall first see whether there is anything common between the 7 squared and the n squared, of which I think there is nothing common. But because the first term is squared and the second one is squared and the sign in the middle is subtraction, we shall apply this method and we say 7 squared minus n squared is the same as this difference of two squares. And we say that to use this, we look at the first term, but this time around without the square. Meaning I'll look at the first term, which is 7, without the square, then plus the second term still without the square, plus our second term here is n, then into the first term without the square, that's 7 without the square, minus the second term without the square, and our second term without the square is n. Therefore, the factors of this expression is that we've written this expression as a product of two things. That's the first scenario. Say, if we have the second one, and the question says that factorize 72 m squared minus 2. Obviously here, it looks a little bit confusing to a student, but you always need to remember the basics of factorizing. Here there is 72, here there is 2. This 2 is not squared, this 72 is not squared, so it seems more like we can't apply the identity. But what it takes is always first look at the constants that you're having in front each term. Here we have 72 and here we have 2. Is there anything common that is between 72 and 2? Of which I hope it is there, and 72 can be divided by 2, meaning 2 is a common factor. So whenever you realize that there is a common factor, then start by pulling out that common factor. We shall pull out the common factor, which is 2, into, we look for what is left inside. Here we had 72, all we ask ourselves, what can we multiply with 2 to get 72? You get your calculators and you try and see. What can you multiply with 2 to get 72? It is over 2 over 2. In short, it is 72 by 2. And that value becomes 36. So 36 is what stays here. We have 36. There is also an m squared. And here we have pulled out a 2. So we ask ourselves, what can we multiply with 2 to get 2? Because it's what was there. So we shall have, what we need to multiply with 2 to get 2 is 1. This is 1. And therefore we have 2 into 36 m squared minus 1. Now before we finish, though this is a product of two things, we ask ourselves, is there anything further that we can do about this bracket? If I look at this number in front here, can I write it as something squared, of which I know that 36 is 6 squared. So if this is 6 squared, I'll have 2 into, this is 6 squared, m squared minus 1. Furthermore, I'm trying to see whether I can create something of the first number squared minus the second number squared. So this will be 2 into, hope we agree from what we looked at that if you have a squared times b squared, this can be written as a b everything squared. So if I have 6 squared times m squared, I can write it as 6m but squared. Then minus, we all agree that 1 squared is 1. So this 1 here, I can also write it as 1 squared. In short, I have something like of this kind. This expression now 72 m squared minus 2 has become 2 into 6m, this one alone squared, minus 1 squared. So the question is, this is going to be taken as one number squared, this also another number squared, and the sign in the middle is subtraction. We go back to the identity. The identity says if you have the first number squared minus the second number squared, is the same as writing the first number without the square plus the second number without the square into the first one without the square minus the second one. So this will be, I'll maintain my 2 out into the first bracket. I write the first number here, which is 6m without the square. Then plus the second number without the square, but the second number is 1. Then into the first number without the square, 6m, minus the second number without the square. So this 72 m squared minus 2 can be written as 2 into 6m plus 1 into 6m minus 1. That's how we use the identity to factorize. I'm going to do one more other example to deal with how we use the identity to factorize. Say the third example. If the question says factorize, and the question is we are factorizing 5 a squared b squared minus 45 c squared. What can we do about that? Always what we ask ourselves is to see whether we can write the whole of the first part with one square and the whole of the second part with another square, so that we apply this identity here. If that's the case, I will start by looking for what is common between 5a squared b squared minus 45 c squared. If I look at this, always what's common is compare the figures, the constants that are in front of these terms. I have a 5, I have a 45. I think 5 is common, it's a common factor between 5 and 45. So if it's common, I pull it out. I'll have 5 into, here I've taken away 5, so I'm left with a squared b squared minus, which number do I multiply with 5 to get 45? If you go to the multiples of 5, you'll find that that number is 9. So I have 9c squared. And furthermore, this becomes 5 into a squared b squared. I can just write it as ab, everything squared, from what we have seen in the previous example. Then minus 9 can be written as 3 squared c squared, and this is 5 into ab squared minus this, I can also write it as, this can also be written as 3c, because both of them are having squares. I put the square up and close the brackets. So I'll see that inside the brackets here, I have two numbers, each one of them being squared, and the sign in the middle is subtraction. I go back to the identity. The identity size, I will have 5 into, I write the first number without the square, that's AB, plus the second number without the square, 3C, into, write the first number without the square, AB, minus the second number without the square. And therefore, my 5A squared B squared minus 45C squared becomes 5 into AB plus 3C into AB minus 3C. So that's how we factorize using the difference of two squares. Even if it is in simplification, still you start by looking for whether there is something common, you pull it out, and also you apply the identity and factorize. I'd like to give you at least 3 numbers that you're going to try out using this identity here, so that by the time we come back looking at other quadratic expressions, you may be in position to follow. Say exercise that you're going to try out. The first one is simplify 3. The first one that you're going to do is simplify 3 times 25 squared minus 3 times 75 squared. 3 times 75 squared. Then the second one is factorize. In factorizing, I'm going to give you 2 Romans. The first Roman is 81 minus x squared y squared. Then the second one is we're having 5b squared c squared minus 20 d squared. D squared. You try out those ones and we shall meet in the next lesson. Thank you.